So what I have here is actually a program to complete the square. The only thing you have to remember is the leading coefficient in this particular case has to be 1. It won't quite work with anything else. You can modify it so it does, but just so you're aware up front, the leading coefficient has to be 1. So if we actually want to look at what the program is, it'll probably help figure everything out. The first line is the clear home line, and there's a reason I have to do that. I need to know where each particular output's going to be, and you'll see why later. So I need to clear home so that the screen clears. Coming down here, I prompt the user for A, B, and C, which are the coefficients or the constants from the general form of a quadratic, which is ax squared plus bx plus c. So a is the coefficient of your x squared term, b is your coefficient of your x term, and c is your constant. I also decided to put b over 2 and store it as d, and you'll see why later. There's a reason for that, and it kind of comes out later on when you're going through to complete the square. Once you have a, b, and c, it's really the only thing you need, because my first output, this means the 7th line down, the first number in, I have x plus something, I left it blank, squared. And you notice it's in quotations, which means the output is actually going to put x plus, leave the blank, squared. The second output says in the 7th row down, 4 spaces over, put d. Now don't forget, d is b over 2, and this is something that we should have gone over already in class, or whoever your teacher is probably should have gone over already. If you just take the middle term and divide by 2, that's what you're going to square at the end. What I did also was I set the entire equation equal to 0. So if you're going to factor or solve, it may be needed for the constants to move back and forth. But in this particular case, I just decided to set it equal to 0 and offset it by the constant c minus the b over 2 squared. Since I added b over 2 squared on the top, I have to subtract it here to offset it and make sure that the equation stays true. So the program is actually very simple. If we run it, it'll probably make a lot more sense. So let's run it with a really simple example. 1x squared, remember the leading coefficient has to be 1, plus 2x plus 3, and we end up with the quantity x plus 1 squared plus 2 equals 0. Now, of course, b is even, so when you cut it in half, you get a nice whole number, a nice integer, and you end up with an integer 1 inside your parentheses. Not the case every time. Now watch, when I run this program again, it's going to clear my whole screen, and I want it to do that because I need to know where on the screen I am for my output. So I'm going to run it again. The screen clears. I remember leading coefficient has to be 1. But what if b is odd? So let's call it 3, because then we're going to deal with b over 2, and if you divide an odd number by 2, you're not going to end up with an integer. And let's say plus 9. Well, in this case, we have the 1.5 squared. Now, I understand that 3 over 2 is a pretty easy number to deal with, but if it happens that you need to know it as a fraction, we saved it as d, so the program knows b over 2 as d. So if you want to know it as a fraction, you can say, hey, give me d as a fraction, and there it is, it's 3 over 2. You can actually do the same thing with the constant term if you want to. You can declare c minus d as something, call it some other variable, and if you want to turn that into a fraction too, you could follow the same process we just did for d. It's dependent on how you want to run the program, but this certainly works. Again, leading coefficient has to be 1. You save d, so you can turn that into a fraction, and if you want to even take it a step further, like I said, call c minus b over 2 something else, and what'll happen is you could actually turn that last constant into a fraction as well when you're done, the same way that we just turned d into a fraction.